Hey you, good day, afternoon or night. Engineer Alvarado, Sergio Geronimo and friends. We are team number 2 and we talk about sustainable chemistry. The participants of team is Cervantes Alvarado, Maria Diaz Proa, Jose Manuel, and Cruz Bengucha, Johan Donovan. Okay, please, next please, friend. Okay, chemistry. Chemistry helps to have a good lifestyle for a long time. Everything we can touch, eat, see, create, recycle is matter. And these science studies matter. So everything is chemistry, all right? Please. So we can say chemistry is industry like fabrics, medicines, milk, energy, but next please, friend. Not everything has a good face. Why? Impacted, ecologic impacted. So we have water contamination. Why? Accumulation of one or more substance from the water, and this is bad. Second, air contamination, mixture for solid and gaseous particles in the air. So it's bad too. Third, soil contamination, alteration of my soil by the presence of chemical substance product by man, by myself, okay? Next, please. So the chemical process is composed for raw material, reagents, solvents, energy, okay? We know. So after the effect is the product, the secondary product, and one thing very important, trash. We can a problem with trash, okay? So sustainable chemistry. It's better to prevent the formation of residue than to try up clean after it's formed, okay? Paul Anast. Okay, what is the sustainable chemistry purpose? The synthesis of chemicals and the process that result or eliminate the use and generation for harmful subjects, okay? Paul T. Annas, green chemistry was introduced by Anastas, okay? Science Paul Anastas in his book described the green chemistry and this prevention of contamination in chemical products don't use so many toxic reagents. So this directive relates to sustainability. So
Hi, my name is Maria and I'm going to talk about the history context. On December of 1984, in India, there was an emission of pesticide gas no control that killed hundreds of thousands people. This caused the industry awareness introducing a responsible care. This catastrophe was a really big, huge problem in that for all of chemistry in the history because they make all the people think that chemistry are very bad for the ecology, but not. After that, they create a lot of programs that help to the recycle and all of this about the green chemistry that is what I'm going to show you. In 1999, the Pollution Prevention Act state the reduction from landfills as a priority for solve the problems environmental. Now I'm going to talk about the organization in care of the development of sustainable chemistry. We have in America green chemistry that is involved in the investigation about synthetic alternative methods. In United Kingdom, we have the Green Chemistry Network. In Italy, we have the INCA, University Consortium. In Australia, we have Center of Green Chemistry from the Monash University. In Japan, Green and Sustainable Network. In Europe, was created technological platform of sustainable chemistry Sustentable that groups, organizations, and people who are related with the sustainable chemistry. And in Spain, we have the platform Petecus, now Sustentable Spain. Research and action lines. New synthetic concepts. Reduce the number of phases, higher energy efficiency, less consume of raw materials, use of renewable raw materials, and avoid the formation of byproducts and waste. Catalytic transformation. The catalysts produce key contributions in the production of clean fuels, irreversible of raw materials, sustainable energy, and protect the environmental. Biotechnology process. Use of the genetic engineering and analytical techniques of high efficiency for speed up the biocatalysis and the development of new, more economic process. Intensification. More production, less energy consumed, small amounts of solvents, less risk, less environmental impact, and high selectivity with transformation of similar or more reactivity. We have the purification and formulation. Production with zero emissions, purification of sustainable amounts of products, cheaper, reducing the consumption of energy and material at less than 25%, and the production of waste at less than 20% minor than new technologies. Polymers. The investigation in raw materials innovate biotransformation, structural design, and design for the biodegradability are areas of promising. Examples of raw materials are CO2, soja, corn, and glucose. Methodology, synthetic, more efficient. It is about develop products with a higher efficiency, reducing his waste, and having a higher atomic economy. We have the dissolvents. It has been chosen the use of CO2, which presents advantage for not being toxic, flammable, cheaper, and it can be divided the product by distillation. Other mild solvent is the water, which have properties hydrophobic, a constant dielectric as acetone, a ionic product that convert an acid into a strong base. Unconventional techniques is based in the application of photochemic process or electrochemical or the activation by microwave, especially in this last, having investigations since 1993 with a big success, getting a heating speed use in solvents that need a lot of energy in question of seconds. That's a big hit.
Hi, my my name is Sherman, and I will talk about education. Education. The next generation of scientists must be entrenched in the methodology, the techniques, and the general basics of the substantive chemistry. A lot of chemistry challenge and land education projects in this discipline with the development of books. Lancer. Cases studied experiments of laboratory. Next, please. Next, please. Objects. And number one, promote the quality to education and to research in green chemistry. Two, empower the cooperation between members, the impulses of green initiatives, the exchanges of experience and knowledge. Three, foment the relation with others, organizations, and scientific institutes. Next, please. Project 4, present project of cooperative investigation for the different public programs. Number 5, design the capacity of investigation and innovation of his member forward the scientific community. And 6, promote the transformation of technology reunions between the centers of ID and company. Next, please. New work area. Number 1, use of materials coming from renewable sources. 2, atomic economy. 3, use of solvents more clean. 4, catalysis. 5, biocatalysis. 6, photochemistry and photocatalysis. 7, biodegradable polymers. Technique. Biotransformation. It works with unconventional solvents, unique liquids, catalytic transformation, use of alternative techniques for the supply of energy in chemistry process, electrochemistry. Master in sustainable chemistry and green chemistry. Industrial beyond transformation, bending solvents, photochemistry, and electrochemistry sustentable. Hemolysis catalysis, basic concept in sustainable chemistry, raw materials renewable, industrial applications, chemistry in water and solvent bending, and reactions with solvents microwave.
Well, Professor, this was our presentation by the second team. We want to thanks, and that's all. Thank you.
Thank you, teacher.
Thank you.